Imagine having to throw away around 40% of your harvest. For many Ghanaian farmers, this is the reality that they face every year after their harvest.
Welcome to our presentation. Next to me is Sam van Beckham, and on the other side is Pepijn van Seters, and they both study mechanical engineering. And my name is Jen van Maklenberg, and I study architecture. And we do this project for our minor International Entrepreneurship and Development. These are the topics that we will discuss in our presentation. The place we will visit is Wenchi, a town in the Bono region of Ghana. The main religion is Christianity and the primarily spoken language is Twi, though the official language is English. Farming plays a central role in the local economy. Important crops consist of cashew, mango, yams, cassava, and maize. Farming is also embedded in the culture. There's even a holiday dedicated to honor ancestors and its land fertility at Akwasiai. The culture map made by the Dutch water authorities shows the differences and similarities between both cultures. In this map, you can see that the main differences are the direct and indirect culture. The stakeholders involved in this project are our project provider Norbert Corante. He's a PhD candidate who has done research about post-harvest losses and is a lecturer at the Wenchi Agricultural College. He has also chosen 4 students with whom we will build and design a cooling chamber and solar dry it together. They can help us keeping it achievable and accessible for all. Our project is part of a bigger project named the ACHI project. The goal of this project is to build capacity and improve the practical education in the field of horticulture and introduce entrepreneurial skills. Lindsay is a founder of this project and has visited Ghana many times and has a lot of knowledge about the project and culture. Esther focuses more on the educational side. And at last, this is a TU Delft minor where Ellen van Andel is our supervisor. The problem in Ghana right now is the lack of a cold storage after crops are harvested. Farmers don't have a lot of produce, and if the demand is low, they can only sell their produce for a low price. A cooling chamber or solar dryer could be a solution to this problem, though not all farmers are familiar with these techniques or don't have the money to buy it.
Then on to the problem analysis. For the problem analysis, we did a 5 why test. This resulted in the root problem being the lack of access to an affordable cooling chamber and also an affordable solar dryer. Yeah, and then on to the project goal. The goal for this project is to reduce post-harvest losses together with the students from Wenchi by building a cooling chamber and a solar dryer. Our second goal is to inform the students of these and farmers of these new techniques. This will be done by giving workshops, lectures, and we're going to write a building manual together. Okay, so the cooling chamber, how does it actually work? The chamber works by having charcoal walls, which we wet from the top side. This water will then evaporate, and in the process it will pull the heat from the inside, just reducing the temperature by approximately 10 degrees. The cooling chamber can hold all types of produce that stay cool in a cool and humid environment, like tomatoes or cucumbers. The shelf life of these produce is extended to up to 2 weeks, and the system only requires a semi-constant water supply.
The solar dryer is a post-harvest processing machine that dries fruits, vegetables, and grains within days. The dryer uses only solar energy, heating up air that rises up and passes the harvest in the chamber of the machine. Therefore, the machine has no running costs. It enables farmers to dry hygienically and safe from unpredictable weather conditions. This is an example from 4 industrial design students who built the solar dryer in the Volta region. We will also visit the solar dryer to get the feedback from the users and apply this in our own design.
To really validate our techniques, we have built a small cooling chamber. Such a cooling chamber can be used for transporting your crops or just small-scale storage. On the right, you see our cooling chamber. It's made out of 2 boxes put in each other surrounded with charcoal. We watered the box twice a day and the results were very promising. Within a few hours we saw a decrease in temperature of more than 2 degrees and increased humidity up to 85%. Its higher humidity keeps the crops longer fresh, and it was really something you can feel when comparing the two crops inside and outside the chamber. We expect the cooling rates to be much higher in Ghana because of increased water evaporation. For our 3-month travel to Ghana, we've made a general timeline with some important milestones. In our first week, we want to adjust to the country and do some research by visiting a cooling chamber and a solar dryer. After we have done this, we want to complete our designs and start building the cooling chamber. Together with the students at the school, we want to finish the build of the cooling chamber in week 3 and perform some testing on it and see how it performs. After making adjustments, we make an easy to use and understand manual and make our findings open source so everyone can just reach out to it. After that, we will go on with building the solar dryer, which is planned to be finished in week 11. After that, we'll also do some testing on it and also write a good manual for this. In our last week, we want to organize an event for local farmers and students to really inspire them about our technologies, ask any questions and try to help them with the last things. Right, every project has some risks. I want to talk about 3 main risks we have considered. To start with the first technical issues, we're building with techniques and the worst thing that can happen is if these techniques just don't work. For instance, with the cooling chamber, we can have some troubles with humidity because the climate in Ghana is very different than here in the Netherlands. This could just result in bad results and could mean that our techniques won't be implemented. The second big risk is the cultural resistance. In Ghana, they are really a farming country and use traditional methods in their farming use. So they could have some resistance by adapting these new techniques. What I want to do to improve this is really work together with them and also make use of their knowledge. The last risk that we want to look at is a financial problem. It can be quite an investment to make a cooling chamber or a solar dryer, and this might just be too much for the farmers. The business model is just not viable. To conquer this, we want to look at other techniques that could still provide kind of the same results, but at a way lower cost.
To ensure the continuation after the installation of our project, we want to implement 3 main things. First, we want to explore the idea of creating a startup with the students from Wenchi. This startup will focus on supplying the needed materials for the cooling chamber and the solar dryer, thereby reducing the cost by buying in bulk and delivering only the necessary materials to the farmers who want to build the cooling chamber or solar dryer. Secondly, we want to create a building material manual together with the students at Norbert, which he can again later implement in his classes, and which can also be distributed so that everybody knows how to make the cooling chamber. Lastly, of course, the ACHI project. It has already been going on for 4 years, and after we leave Wenchi, the project will continue for many more there.
Okay, we are farming for the future. Our goal is to reduce the post-harvest losses in Ghana by building a cooling chamber and a solar dryer and really work together with the students and the local community there. We want to thank you for listening and see you guys soon. Bye!